And here we go, the final part, part D. Let's see. So given that the radio is working after 16 hours, so find the probability that the radio will be working after being used for another 9 hours. So first thing to notice is that we're using a given that question. So every time you have a given that question, we know that the probability is going to be on the bottom half of the fraction. And it says after 16 hours. So this is immediately x greater than this variable. One thing to know, we're working in tens of hours, and as you recall from part C, when it said find the probability that radio will be working after 25 hours, this literally meant x greater than 2.5 because of the tens of hours system. So literally this means x greater than 1.6. So let's go over here, solution for D. We know firstly that the bottom variable, the given that part, would be x greater than 1.6. So it looks like we need to solve that. Now, for this plus statement, find the probability that the radio will be working after being used for another 9 hours. Notice how to use the word another 9 hours. So this literally means after the original 16 plus 9 hours, which is actually 25, which is actually what we did for B and C. However, be very careful here, yeah? We're talking specifically about the radio, meaning the radio requires 2 batteries, meaning we'd only care about this probability, not this one. This is the battery. Okay, so this is actually a common mistake here, very common mistake, so be very careful. We want the radio, which is 9 over 64. So instantly, this is actually officially written as x greater than 2.5. Now, one thing before I forget to know as well is because we're using a radio for both of them, remember they're both radios, we're going to have to square both of them because we need 2 of them, yeah? That's exactly what we did earlier. I know we multiplied both twice, but it's the same by just squaring. And okay, so we know what we have. So the solution to part C, which we already had, was 9 over 64. So this squared was 9 over 64. That's okay. Now let's try and work out this probability, x greater than 1.6. Okay, so this is quite fine. Now this is just standard procedure here. You just take the density function, integrate from the limits, so from 1.6 onwards all the way to 4, and you just smash it in. So let's do it. So 1 over 9 outside, integrate from 1.6 to 4, you should get 4x minus x squared and then dx. Easy. Now, just to get into the standard format before I just give you the pop out the answers, 4x is 4x squared over 2 or 2x squared, and then this is x cubed over 3, and yeah, 1.6 and 4. Okay, so as per usual, plug in 4 over here and then find the result, and then plug in 1.6 over here and then evaluate all, find the difference and multiply by 1 over 9. You should get 96 over 125. Now this is this probability. To get the squared version, well, let's square this result in our calculator. So 96 over 125 squared. Oh god, that's one ugly probability. Well, I'm not going to keep it. I'm just going to write as it is. So it'll be 96 over 125 squared. And then plug in everything in. 9 divided by 64 over the answer. Ooh, you should get about, let's say 4 decimal places. 0.2384. And that's it. Case closed. This is part D for you guys. And I hope this helped. This is kind of a very risky question because they're talking about specifically radios, yeah? So always, be careful what you're trying to find here, yeah? They both need 2 batteries, hence why they're squared.